Planets were wandering stars long before telescopes because they moved in odd ways relative to the other bright objects in the sky. Scientists didn't look for them so much as notice them. Now, with the telescopes and capable hands, we've been discovering one bright object after another. NASA's planet-hunting spacecraft TESS has struck pay dirt again. The spacecraft has located 2 new super-Earths orbiting a star only 33 light-years away. At 33 light-years away, the destination is the red dwarf star HD 260655. The star is among the brightest in its class in the solar neighborhood, though smaller than ours. Circling this bright M-dwarf star are 2 terrestrial Earth-sized planets. Both planets are rocky super-Earths. With their orbits tight and the planets exposed to temperatures that are too high to sustain liquid surface water, the word Earth is only figurative, as the rocky worlds are likely not habitable. But scientists still think of these planets to be of further observation. The HD 260655b and HD 260655c are among the closest known rocky planets yet uncovered outside our solar system that astronomers can watch scratching the faces of their stars. It is almost secure to say that both the planets are tidally locked. So counting on where you are, there is either permanent day, permanent night, or permanent twilight. Besides that, M-dwarfs make terrible for surface life, as they are also known to blast their systems with intense amounts of radiation every so often. The opportunity to study 2 rocky planets in the same system is too good to pass up, even though both the planets are no Earth analog and are more likely to be a mini-Neptune gas planet baked away by radiation blasts. We've already confirmed more than 5,000 exoplanets in the Milky Way to date, and the push keeps growing with astrobiologists' curiosity about finding terrestrial or rocky worlds like Earth, Venus, and Mars. The HD 260655b and c and other rocky exoplanets are already on the list of observational targets for the James Webb Space Telescope, soon to deliver its first science images. This telescope can analyze how rocky planets can be different from each other and will deliver clues to how rocky planets form. It will even tell if biological life is on planets by dissecting the makeup of the atmospheres. This telescope could make quite a lot out of a star's light shining through these planets' atmospheres. The brightness, along with the proximity of the star, will show scientists fingerprints of molecules within the atmosphere. And it will also give a more intimate look at the properties of the planets and signs of any atmosphere they may hold. Both planets in this system are considered among the best targets for atmospheric study because of the brightness of their star, says Michelle Kunimoto, a postdoc at MIT's Kavli Institute for Astrophysics and Space Research. Is there a volatile, rich atmosphere around these planets? And are there signs of water or carbon-based species? These planets are fantastic test beds for those explorations. Learning more about the atmospheres of rocky planets will help scientists understand the formation and development of worlds like our own, says a researcher at the Institute of Astrophysics in Andalusia. Multiplanetary systems propose a unique opportunity for characterization through relative planetology, as they are formed within the same protoplanetary disk. The new planetary system was originally pinpointed by NASA's satellite TESS, or Transiting Exoplanet Survey Satellite. TESS is an MIT-led mission prepared to observe the nearest and brightest stars and detect periodic dips in light that could signal a passing planet. In addition to statements made by TESS to verify the existence of 2 new planets, the scientific team has also employed ground-based instrumentation, such as the CARMENE spectrographs and HIRES. The team combined the measurements to pin down the properties of both planets, including their orbital period and size, which has assembled the density and confirmed that they are rocky worlds. Since the host star has a solar mass of only 0.4, the super-Earths exhibit more impact on it. This makes counting the planet's masses and densities easier. They found the inner planet, dubbed HD 260655b, is about twice as massive as the Earth and orbits the star every 2.8 days. The second outer planet, HD 260655c, is about 3 Earth masses and orbits every 5.7 days. And this may or may not be good, but the mass of the planets makes a lot more gravity and a thick atmosphere. The team estimated each planet's density from its size and mass and found that the inner, smaller planet is slightly denser than Earth, while the outer, larger planet is a bit less dense. Both planets, based on their density, are likely terrestrial, and thus were concluded in composition rocky. Their short orbits speak for themselves for having an exterior at a roasting 710 Kelvin and 560 Kelvin of the two planets respectively. While it is no need to say, this range is outside the habitable zone, too hot for liquid water to exist. But on the bright side, there might be more planets in this system which might have life. As these planets are close to their stars and have a small orbit, both the super-Earths have lost their atmospheres, which is not much of a surprise. While there are no signs for Planet B to have an atmosphere being so much closer to its star, Planet C most likely had an atmosphere of hydrogen or helium that was stripped away. But if they're wrong about the composition and it's more like Earth's, then it may have held onto a water-dominated atmosphere. In both cases, if the planets have atmospheres, they're highly unlikely to have raised hydrogen atmospheres. While red dwarfs are known to host Earth-like planets in their habitable zones, they can erupt violently, causing their habitable zones uninhabitable, or so it is thought. So, while these two planets are far too hot for surface water and life, astronomers can use them to learn more about all those other planets orbiting all those other red dwarfs. Many multi-planet systems are hosting 5 or 6 planets, mainly around small stars like this one. Hopefully we will find more, and one might be in the habitable zone. That's positive thinking. A lot of planets being discovered are very close to being in the Goldilocks zone. Even Mars and Venus are both within the range of distance with the right temperatures for water and other factors, yet neither are capable of supporting life as we know it. So, a number of the to-be-discovered Earth-like worlds would be compatible with our type of life, but a fair amount of them would be just like our closest neighbors. Even though we find a habitable planet, it would take loads of time to send a signal there. A civilization could have an industrial revolution and develop space travel in that time, or wipe itself out. They are so far away that unless we stumble on some faster-than-light technology, there is no way to visit distant worlds in the near future. We are now finding evidence that humans can spread through the stars and explore other worlds, yet we lack the technology to do so. But it is much less that we lack the technology to do so, but that we lack the motivation to do so. During the space race, technology advanced at an incredible rate, and even though it is all ancient compared to what we have today, we still managed to drive around on the moon using it. Before we worry about the technological constraints of interstellar colonization, we first need to start having humans explore our solar system. In doing so, we would develop countless technologies that would help us survive in deep space for extended periods, among countless other things, and colonize our planetary system. So the more you think about it, it is the cosmic equivalent of staring through the window of a sweet shop. That's all for today. If you enjoyed this video, let us know what you would like the next video to be about. I'll be reading you in the comments. And don't forget to hit the subscribe button and notification bell for future updates. See you soon.